Hi guys, welcome to this lecture, Primary Production and Nutrient Cycling. So let's get things started. First we have what is primary production. Primary production is all the new organic matter introduced to an ecosystem by the autotrophs or the plants. We have gross and net. So gross is a total, and net's what's left over after the plants use it for themselves. Trophic level. So we have the trophic level is the amount of energy transfers from the bottom. So primary consumer is primary because the first things that eat the plants. And trophic cascade, we have top down and bottom up. But we'll focus on bottom up for now since that's more important in nutrient cycling. So that just means, we have all the nutrients from the algae, which gets eaten by a frog, which gets eaten by a snake, and each one of those times, the nutrients will transfer to the next organism. So, what are nutrient cycles and major components of that? So we're say of a pool, and no, not a swimming pool, but a pool is just the total amount of nutrients in an ecosystem. We have the flux, which is the intemporal rate of in and out, so how much goes in, how much goes out over a given time, and the residence time, how much time does this element stay in the ecosystem or the pool. And then the turnover rate is just, total time, total rate it takes for the entire element to cycle through the ecosystem. First, we have carbon cycles. Carbon is a very important molecule. This one usually comes from the CO2 in the atmosphere. So plants will take it from the atmosphere, convert it into their own structures, and then whatever eats the plants uses the carbon from the plants, etc., and it goes down the web. But we should also talk about the Keeling curve, which I like to think about is Keeling the planet. The Keeling curve just shows the dramatic increase in carbon CO2 levels over time. At the beginning of the chart, it's like 100 parts per million less than where it's at now. We all know that's human related, so don't litter. Uh, Next element we should talk about is the nitrogen cycle. The nitrogen cycle, instead of by plants, is fixed by microbes, and then you have ammonification, nitrification, and then denitrification, which are the different processes by which bacteria and fungi um, absorb nitrogen, which usually comes in the form of ammonia or urea, and then they can also, take it back from those states and back into N2. So next we have is the phosphorus cycle, which this one's more related to fertilizers and that sort of thing. And phosphorus is a limiting nutrient in most ecosystems, so this one often leads to algal blooms when people don't know how to dispose of fertilizer correctly. Next we have is the human impact on these. So like I said, nitrogen and phosphorus are limiting nutrients, and together humans have been dumping a ridiculous amount of them, which creates algal blooms, which eventually kill everything because when everything dies, the respiration from all the fungi and everything absorbs all the. Also, on top of the dumping nitrogen and phosphorus, humans will start dumping crazy amounts of iron, which increases the phytoplankton and leads to giant algal blooms and then eventually huge swaths of death from the oxygen deprivation as well. And so what can we do is don't litter and don't dump a bunch of fertilizer into the ocean.